G'day students. Okay, what we're going to do in this video is continue with the process of teaching you how to sketch a graph straight from its equation. So we'll start by looking at some somewhat simpler graphs than normal. These are ones that actually pass through the origin, which means we already know one of the points that lies on the graph is at the origin. So I can put a point just there. Oops, let me go try that one again. Okay, now we learned in the last video that the number that x is multiplied by is the gradient. So the gradient in this case is 2. Now I want to write that as a fraction so I can use rise over run to plot the second point. And any whole number can always be written as a fraction with 1 in the denominator. So to find a second point that lies on the graph, starting from the origin, where my first point is, the rise is 2, the run is 1. Let me go pick up the point. The rise is 2, the run is 1, and there's the second point. And it's always a good idea, if possible, to plot 3 points, just in case you make a mistake. So from that point, the rise is 2, the run is 1, and if all the points lie in a straight line, which it looks like they do, then that's where the line's going to be. So I'll just grab my ruler, put the 0, in this case, at the origin, spin it around like so. That doesn't look too bad. And that looks reasonably good. Okay, let's go ahead and draw the line and remove the ruler. And there's the graph of y equals 2x, which passes through the origin. The y-intercept is 0. That's why there's no constant term on the end. Okay, having a look at this next one. Okay, we've got a gradient of negative 2/3. Well, once again, we've got to put that negative either on the 2 or on the 3, and either one will work. And again, we're going to plot 3 points. So the general rule is plot 3 points. You need 1 point to start from. You need the second point to get the line. So in this case, my rise is negative 2. My run is positive 3. And as a check, I do that again. My run is negative 2. Sorry, my rise is negative 2. My run is positive 3. All the points should lie in a straight line. If they don't, I've made a mistake. Put the 0 point on the, gotta grab it from there. There we go, that's a bit better. And put that through the point. That's pretty close to what I want. Slide the ruler and rule it up like so. Okay, and there's the line or the graph of the equation y equals negative 2/3 x. Okay, let's look at some slightly more complicated equations. Okay, so we've got about 5 of these to do, so this video is going to go on a bit longer than normal because we want to look at a variety of different types of equations. So here's the equation just here, y equals negative 2/3 x plus 2. And what I'm going to do here is pretty much going to be repeated in all of the other pages in this video. So the first thing we have to always start with is finding the y-intercept. Well, we know from a previous video that the coefficient on x is the gradient, the constant term is the y-intercept. So in this case, the y-intercept c is 2. Or if you want it as coordinates, 0, 2. You don't run at all, you stay on the y-axis and you jump up 2. So let's go ahead and plot that one. So there's the first point on our graph. Oh, I might just place that a bit more accurately. Okay, find the gradient of the line. Well, once again, that negative sign has to go on either the top or the bottom. Usually just put it on the top. So the gradient, rise over run, is -2/3. And once again, what I can do there is from that point, not from the origin, but from the point that's on the graph, I have a rise of -2 and a run of 3. I have, from that point, a rise of -2 and a run of 3. And all the points need to lie in a straight line. So I think I'll skip my ruler and just use my straight line tool this time. It's almost faster to do that. And that's that way, and I'll go the other direction. And I think that's not too bad. So there's the graph of y equals -2/3 x plus 2. So looking at the process again, start by plotting the y-intercept, which is the constant term. Whoops. Might help if I went back to my writing tool and undid what I wrote. So let's see if that's fixed it. Yes, there we go. So the y-intercept is the constant term, so that's where it crosses the y-axis. Then find the gradient, write it as a fraction, rise over run, plot a second point, and just to be sure, plot a third point, and then draw the straight line that passes through those 3 points. Okay, let's have a look at another equation. This one's fairly straightforward. Y equals -3x take 5. Once again, the constant term is the y-intercept, which is -5. So C equals -5, or as coordinates 0, -5. So we plot that point first. Okay, the gradient is -3. Well, we have to write that as a fraction, so we just put it over 1. And the rise over run is -3/1. Let's go ahead and plot 2 more points. So again, we don't start at the origin. This is the common mistake that students make, is they keep wanting to go back and measuring from there. It's from a point that's already on the graph. So in this case, starting from that point, our rise is -3, 1, 2, 3. Our run is 1. And I can't go any further on that. So what I could do, if I wanted to get a second point just to test it, another way to get -3 is to write it as 3 over -1. And that means starting from that point, it means I go up 3 and back 1. And that gives me a third point. Oops, let's get that a bit more accurate. A third point on the graph. Okay, let's just go ahead now and use our straight line tool to draw that. And then I'll extend it in the other direction. So that's not much good. Let's see, I need to go up 3, 1, 2, 3. That looks pretty good to me. And there's the graph of y equals -3x take 5. Okay, maybe to keep this video a little bit shorter, we might skip some of these. I think you might have the basic idea. This one probably is worth doing because it's a bit special. Notice that there is, in this one, there's no x term. So really the equation of that is y equals 0 times x plus 4. So the gradient is actually 0. So I've got to put 0, got to make it into a fraction. So I've got to choose something for my denominator. It doesn't matter because 0 over anything is 0. So I'll just put a 4 there. Okay, the y-intercept is 4. Or again, as coordinates, it's 0, 4. So let's go and plot the y-intercept. It's at +4. And the gradient is 0, which basically means that I'm going to rise not at all, and I'm going to run 4. I'm going to rise not at all, and I'm going to run 4. And as you can see, all the points end up lying on a horizontal line. So let's go ahead and sketch the graph of that function. I'll just do it in 2 directions, and it's something like so. So the equation y equals 4 turns out to just be the graph of a horizontal line. Okay, I don't think I'll do this one, but I'll just quickly go through just a reminder that that is really, I've done it again, maybe I'll learn one day. That is really a plus negative, so that's really negative 4x plus 2. So the y-intercept is 2, the gradient is negative 4, which you can write as negative 4 over 1, and then plot your points. So if you've got the x term second, not a drama, just remember that the coefficient on x is the gradient, and therefore the first term is going to be the y-intercept. If you've got x or negative x on 5, that's another way of writing for the gradient. That's really negative 1/5 x. So the 1 in front of that, the negative sign goes on to the 1, and the gradient is negative 1 on 5, and the y-intercept is negative 4. So again, plot the point. Let's quickly do this one. Plot the point at negative 4. That's the y-intercept. And then for the next point, the rise is negative 1. The gradient is 5. The rise is negative 1. Not the gradient, the run is 5. And we go ahead and draw the straight line. And then I've got to extend it in the opposite direction like so. So there's the graph of y equals negative x on 5, subtract 4. I think there might be one more to go. Okay, oh, this is a bit tricky. In fact, what I might do is stop there, and I might do the next page as a separate video.